Okay. I have a few minutes. I thought I would take a look at the GCC source code. I only have a few minutes, maybe about 20 minutes, so I won't be able to get very far. I'm looking at it at a couple of places. One is the GCC mirror that's on GitHub, and the other is whatever this is, the Git, the GNU.org Git web interface. They seem to be synchronized pretty well because the latest commit on master on the official Git web repo is this I386 relax extract location operand blah blah blah, and that's the same thing we see here on GitHub. So I have faith that I'm browsing on master. I probably won't really use this Git web thing. I guess I'm going to bookmark it and close this tab just so it gets out of my way. Okay, so I haven't ever really looked at the source code to GCC before. I don't know a lot about compilers. So I'm just kind of going into this blind. I see a directory named GCC. I assume that that's probably an important directory. Libatomic, libada, libgfortran. So these are libs, libffi. So Fortran's a language, obviously. GM2, I don't know. libgo is, I assume, possibly a reference to the Go language. So maybe we're mixing up here various libraries. Some are for languages. I don't know if that means it's like a backend. Failed to load latest commit information. So the runtime support library for the Go program. Okay, yes, that is Go. Fortran, I assume, is something similar, but there's no README. I want to choose something that like Phobos. I don't really know what Phobos is. Or libIberty. I'm just curious what other kinds of libraries there are. The Liberty Library of Free Software. It's a collection of subroutines used by various GNU programs. Okay, so some of these directories, it looks like, are language runtime type things, and some of them are just other things. So I'm not sure what all the different types of other things there might be in a project as gigantic as a compiler that's been around as long as GCC has. So I don't, at least as of now, I'm not sure whether digging into those directories at random, as I want to do, is going to be the most fruitful thing for me to spend my time doing. So I'm going to dig into this GCC directory. Okay, and here we get some like languages, Ada, Analyzer. I'm curious what that is. C, I assume, is the C language. Common. I wonder what CP is. Changelog? No. Let's look at CP trait. I don't know. Okay. So this analyzer directory looks already pretty cool. It's got an analysis plan, analyzer language. Let's see if there's a README. Nope. All right. So I think I want to look at this in a little bit. Oh, we have Rust here. A test suite. Is this all of the tests? This is a collection of tests for GCC. For further information about the C test suite, see readme.gcc. The driver that runs this test suite is called Deja GNU, and you will need a current Deja GNU snapshot. Okay. The tests, I'm sure, are interesting, but I'm not going to go into them just now. again, just because I'm limited on time and I want to kind of get a feel for the code base overall. Lots of change logs. I assume these are years. Let's see. Obviously 1997 is where we want to be. Yep, 1997. Okay, so what was going on in 1997? I don't know. Some Makevar stuff, a bunch of abbreviations that I don't understand. I assume these are mainly like files, and these are, header and C files that were changed. Okay, so in GCC, I guess let's look at common. D, I'm going to guess, is the D language. The Digital Mars D compiler. D-lang. Okay, yeah. C family, I'm going to guess that has some C++ stuff in it. Although Objective-C gets its own directory. Does CPP? Did I miss CPP? Is this just one C++? I don't know. Okay, ASAN. Yeah, I'll look at the ASAN source. The tribs auto profile backend. I do want to look at the backend. Bitmap. Now, why would it have its own bitmap? I'm sure there's a very good reason. Cleanup. I'm not sure what these things are. I'm wondering if this is partially optimization stuff. Color macros, context. Yeah, I'm curious about what context is up to. CPP default. Data streamer, DCE. Diagnostic core. Do jump. Are those like go-tos? And then some I think dwarf is a binary format. Let's look that up. A debugging format. Okay. Is expra an expression? Fibonacci heap. Those are very popular among programming interview tutorials. I'm not sure I've actually seen one in the wild yet, until now. And then Gimple, I'm pretty sure is an intermediate representation for GCC, but beyond that, I don't know. So there's a bunch of Gimple stuff. I'm mildly surprised that Gimple doesn't get its own directory just for organization's sake. Host hooks. In fact, this whole directory is pretty ginormous. IPA. I'm not sure what IPA is, but I'll take a look at it. We have JSON. I'm not going to look at that. Loop unroll. I guess that's what unroll loops does in Gen 2. Memory block. Yeah, I'm kind of curious about memory block, all this stuff. Opts. Okay. That's about the limit of things that I think I can look at in the next few minutes. Oh, hey, there's a splay tree. Another data structure made famous by coding interviews. No, of course they're famous outside of coding interviews, but I guess unless you work on relatively low-level stuff, you're not really likely to come across one. So what am I looking at? I'm looking at expression, or what I assume is expression, expr. Okay, we have some defines. Okay, so we've got a structure called separate ops. It's used to pass around information about exploded unary, binary, and trinary expressions between expand, expr real one, and friends. Okay, so I'm assuming that and friends means that this expand expr real one has things like helper functions or other functions that are commonly called in the same, the same location or same parts of the code, and they use this separate ops as a structure. It's got a tree code. Don't know what that is, a location, and type, and op1, op2, and op0. Okay. Tree. So where's tree defined? All right. So RTX I vaguely recall as being one of the registers in, is it the x86 standard? Maybe I'm wrong. There are lots of X's. Okay, so maybe not. All right, so I'm not sure what maybe RTX is an abbreviation for something. So we've got data mode, emit block move hints, generate a non-consecutive group of registers. Well, it says registers. Generate a non-consecutive group of registers represented by a parallel. Mark reg as holding a parameter for the next call. Insin. Okay, so this seems to be doing registry stuff. Generate several move instructions to store len bytes generated by const fun to block 2. So extern store by piece is going to return an RTX. It's going to take an RTX, a host wide int, by pieces const fn. All right, generate code for computing expression exp and storing the value into target. Okay, so this is it seems like pretty low level-y stuff. I guess that's not surprising. So what is expr trying to tell me? I guess we're working with expressions and maybe generating assembly code. I don't know, but that's kind of the feeling I have. Oh, here's experts.cc. I think I must have been looking at the header. Was I? Yeah. Okay. So set source. Blah, blah, blah. Okay, so this is a void function. I'm just curious to see something that returns something. We have a GCC assert. If get code from is equal to preserve subreg promoted var p if the new mode is wider than the original mode but narrower than the inner mode. Like convert move, but deals only with scalar modes. Okay. I don't know anything about, I don't know enough about assembly to really have my, bearings with respect to the assembly stuff. And the The method names are a little bit on the opaque side. They have lots of, what's the word? I guess like abbreviations, like just squishing words to save typing. Okay, so Gimple fold. Let's see what we got here. We've got more external trees, maybe fold and comparisons. Optimize atomic compare exchange. Gimple build functionally matching fold, build, and output statements. Output, I assume this is statements. Statements int the provided in, maybe in. Is it a typo or is it an int? I think it's maybe a typo. In the provided sequence, matching and simplifying them on the fly. It's supposed to replace force Gimple operand. Okay. So we've got a bunch of overloaded, Gimple builds. So these are, I guess, building the Gimple tree, maybe the abstract syntax tree, if that's how Gimple works. Tree vec extract. Okay. What is this? This is Gimple fold. Okay. Static pool. Get range strlen. Return. Okay. So can defer decal in current unit P. So this is going to return true when decal can be referenced from current unit. From decal, if non-null, specify constructor of variable decal was taken from. Specify the constructor of variable decal was taken. We can get declarations that are not possible to reference from various reasons. Okay, so this is maybe some sort of sanity check. So how can we get references? We can get declarations that are not possible to reference for various reasons. When analyzing C++ virtual tables, they don't have known constructors, even when they are keyed to other compilation units. Those tables can contain pointers to methods and vars in other units. Those methods have both static and external set. Okay, so this returns true when decal can be... Okay, I see. When it can be referenced from the current unit. I'm guessing unit means the same as compilation unit. In Whopper mode, devirtualization might lead to reference to method that was partitioned elsewhere. In this case, we have static var decal or function decal. In comdat functions referred by external vtables that we devirtualize only during final compilation stage. All right. If tree public. So tree static. So these are like macros that I guess check whether a tree is static or public. If decal external. Okay. Canonicalize constructor val. Okay. I'm going to move along. Gimple expression. Is Gimple addressable? Is Gimple constant? Gimple call, adder, findecal. Useless type conversion. Return true if the conversion from inner type to outer type is a useless type conversion. Otherwise, return false. Okay. The function implicitly defines the middle end. It implicitly defines the middle end type system. Is Gimple the middle end? Let's see if the internet knows. It is an intermediate representation on the tree data structure. Hey, look at this. This looks like useful Useful stuff to read. Okay, a tree is a pointer to a union tree node. All right. Is this like I assume this is the union structure that I know and love from outside of the GCC code base. So tree node is a union of various structures that have the first. Oh no, this is like a typed union. Yeah, this is just this is like a C type union. Okay, that had the first field of struct tree common. Okay. So it's a tree is one of these specific trees. Okay. Tree is a tagged structure. A tagged structure. What's the common part? Okay. That's too much unformatted text for me to read with so little time. Okay. Oh, I do want to look at analysis. Did I ever open these? I want to at least see what an analysis plan is. A class to encapsulate decisions about how the analysis should happen. Examples, the order in which functions should be analyzed so that function summaries are created before analysis of call sites that might use them. Yeah. And which call graph edges should use call summaries. The above is a work in progress. What is the above? Is the above the comment? Because there's not much above this to do. Line 32, we have the copyright statement. I assume that's not a work in progress. The if-defs are probably fine. The namespace, I'm sure, is fine, although you could use analyzer. So I assume the work in progress is the comment. Okay, so what is an analysis plan? It's going to take a supergraph and a logger. Huh. Can I get back my... Oh, never mind. So I don't know what a supergraph is. And this thing holds the result of an IPA reverse post order. Okay. Index of each node within the post order ordering accessed via the MUID field. So we're going to, I guess, do a post order traversal on this tree data structure. I'm not sure if the tree is it's the C graph. I don't know what the C graph is, or whether it's so it's a graph, right? So is it more general than a tree? And we've got this super graph thing, which I don't know what it is. Okay. C graph node post order. So we've got the supergraph S and SG and M C graph node post order of some thing. I guess this is a cast, and we're going to take symtab C graph count. What is symtab? Where did symtab come from? I don't know. Okay. M index by, and then we're going to get its UIDs, log some stuff, and IPA reverse post order. We're going to do some sanity checking with assert. And I guess okay. So analysis plan analyzer. So this is, I guess, some sort of code analyzer, maybe like a static analyzer. And so it includes Gimple. I'm just trying to think, what is the API like for building a GCC based static analyzer? Or like, I guess what I mean is building a static analyzer that leverages GCC internals. What I've heard, and I don't I've never verified is that it's much easier that LLVM has intentionally exposed the sort of stuff you would need to leverage the internal representation, and so you get a lot of things that are based on Clang or LLVM, and that GCC has made it hard to do this. So this was something I read on the internet. I don't know whether it's true. I'm just trying to think. I may have this may be related to that whole thing, like writing a static analysis thing. I had thought clicking on this that this was going to be about GCC analyzing the code it was compiling for maybe something like optimizations. So I don't know. I'm just like I said, I haven't seen this code before. I'm just flipping through the code pages here. Okay, so here's analyzer, call summary, checker event, diagnostic engine. We get an exploded graph. That sounds exciting. Oh, here's super graph. Okay, so engine, it just runs checkers. Okay, it's simple enough. Concrete implementation of region model context, wiring it up to the rest of the analysis engine. This is exploded graph. On state leak, on condition, on bounded, on escaped, Gimple, get statement. So yeah, we are definitely in the land of Gimple. We're dealing with the intermediate representation in these files. Okay. I do have to go. Let me see if there's anything I can do on my way out. We have supernode, super edge, and super graph. That just looks like a graph, except you've called everything super. But I assume, like, what is a super graph? It seems like a super graph should be a graph that contains some graph as via a graph embedding. A trait struct describing the family of node, edge, and digraph classes for supergraphs. Let's see if this is something. Analyzer internals. Hey, look at this. Works on the Gimple SSA representation. The implementation is read-only. It doesn't attempt to change anything, just emit warnings. Okay. Okay, I'll read this at some point, but does it tell me what a supergraph is? First, we build a supergraph which combines the call graph and all of the CFGs into a single directed graph. Okay, so yeah, it's a graph that contains other graphs as subgraphs. Okay, what's do jump? Prefer and bit test. Do jump by parts greater. Clear pending stack. Oh, okay. This seems to be doing things with stack frames. Subroutine of do jump dealing with exploded comparisons of the type op0 code op1. All right. Do compare and jump. Okay, cool. There's more do jump stuff. That's the header file. Context SCC. Oh, this is a very short file. A singleton holder of global state. The singleton holder of global state. So this is context just like a singleton pattern thing? Pass management, set pass. I guess this is like how many passes have we done? And that's it. Okay. Alrighty. Is this depth for a search? CFG anal. Okay, so I saw CFG in the documents that I just looked at. I don't know. I don't know, control flow. A control flow graph is a data structure built on top of the intermediate code representation, the RTL or GIMPL instruction stream, abstracting the control flow behavior of a function that is being compiled. It's built on top of the intermediate. The CFG is a directed graph where the vertices represent basic blocks and edges represent possible transfer of control flow from one basic block to another. Okay. That seems a reasonably intuitive thing to do. And I'm guessing this is analysis on the CFG graph is why it's called CFG Anal. Oh, here's the CFG file. Let's see this. Okay, let's look at the header. A structure to group all per function control flow graph data. The X prefixing is necessary because otherwise references to the fields of the struct are interpreted as the defines for backward source compatibility following the definition of the struct. Okay. GTY control flow graph, basic block, X entry block pointer, X images, profile status. Init flow, free CFG, unlink, redirect edge. Okay. Auto flag. All right. Here's the CFG implementation. CFG cleanup. So what do we need to clean up? Set to true when we are running the first pass of try optimize CFG loop. Try cross from to edge, update forwarder flag. Okay. Backend. Is there anything interesting? Nothing really that I see. This is the ASAN. Maybe I'm just curious how big it is. We finally get a code comment, and it's a massive code comment, and this is a giant file. Okay, so I'll have to look at this later. I'm over time that of what I had budgeted to do. Okay, so here's the ASAN header file. Stack magic left, magic middle, magic right. Set sanitize LCAS. All right. Display tree utils. I guess I don't really need. I am curious, but mem model, relaxed, consume, acquire, release. Is this like a virtual, like a an abstract model for memory? I don't know. So memory block pool, free. Let's see. Reduce free list, chunk free. All right, more memory block stuff. Loop unroll. Oh, I have to look at loop unroll. Okay, we get a code comment. Pass performs loop unrolling. We only perform this optimization on innermost loops with single exception because the impact on performance is greatest here and we want to avoid unnecessary code size growth. So this, I guess, reduces the time complexity by making an inner loop into... No, it doesn't reduce the time complexity, but it can, I guess, improve your constant. Okay. So what is the... so unroll loops takes an int and is void. Split edge and insert takes an edge, an RTX insin, and it returns a basic block. Okay. I don't know what that means. What is an IPA predicate? Do this and equals P. Okay. I'm not sure. So here's Gimple. Did I look at this already? I'll have to come back. All the tuples have their operand vector, if present, at the very bottom of the structure. Therefore, the offset required to find the operands vector, the size of the structure minus the size of the one element tree at the end. All right. Okay, so that wasn't a lot of time to look into it, but I think I have a better idea than I did before I looked at the code base at all. All right, that's all.